Hello, and welcome back to Learning with Lee. I know that in the previous episode, I had mentioned that we would be getting into how in particular I'm doing things such as generating a random list, as well as then how I then happen to be printing a list. However, after having gone back over some of the literature on the subject, it's a matter of I feel that there's a few other things that I would like to discuss before we actually get to things such as how to do input and output, as well as some of the extra libraries such as how you use random. So it's a matter of I'm going to push those discussions off for a little bit and cover a few items I think are going to be useful once we actually reach the point of discussing those. It's also a matter of once we get into discussing some of these things, we're going to really get into things that represent a split between C and C++. And some of what I've shown you is already only C++ applicable. However, much of what I have also shown is good for both C as well as C++. So, what we're going to take a look at now is something that exists in both languages, and it is known as a function pointer. And this is going to be useful to know before we get into our next subject, which is classes, so as you can begin to understand how certain things work out. So, what we're going to take a look at here is, let's say that I wanted to allow whoever's calling this method of merge sort recursive and merge sort here to be able to determine whether they want to be greater than or less than. To be fair, and probably the most straightforward and cleanest ways, I could just have it pass in a bool, have it do some other stuff with it. Alternatively, and this happens to be something that I could end up setting up myself, there's a few different ways in which I could have it pass in as an argument here, a function pointer to some comparison function, which now I would have to hand all the way through, and basically replace this right here with, so as that I can end up doing this comparison without having to care whether it's greater than or less than. And the way in which we're going to be actually changing it up here, and sort of to help give you a good idea of how this will be done in the future, is let's head on over to the header file for our linked list. And we're going to modify the struct in here. And what we're going to do in here is we are going to add in a function pointer. Now, for how we actually set up a function pointer, what we do is we first, down here, just as we would any other argument in here, what we're going to want to do is, since it's a comparison, we're going to want to have it return a boolean. Then we have to specify that it's a function pointer, and the way in which you do that is you use these pair of parentheses, the asterisk to represent that it's a pointer to something, and then whatever you want to call it. So I'm just going to call this comp for comparison. And then over here, you have to use another set of parentheses and include the argument, similar to basically these set of parentheses down here. In this case here, we're taking in an int and an int. You don't need to include any names for it. In general, it's a bit clearer to specify that you don't have names in your function pointers. In your functions, you do include the names. It's technically not necessary in your original declaration of a function. You only need the names when you define the function. So up here, I could actually get rid of those names there, and it would still end up building and working. But in here, to help represent the fact that it is a function pointer, we can just do this, and that lets us have our function pointer here. So then, when we want to actually use it, when we come over to here, and we head on down to merge. So what we want to do now is we can just go from, since we have our two lists, and technically this could be a problem in case each of them had a different comparison function, but for now we're just going to assume that they have the same one. So what we can do is if, and then what we would do is go with a list, and then for now we'll just go with blink item, that one there. And we also then have to, of course, head over and go with our comparison here. You can see that it shows it as though it happens to be this bool followed by the, well, right in there. Yep, does that. And then the important thing to note here is that because it's a pointer, we actually have to dereference that pointer. So that means that then, beyond this, and just to be really clear about this, it requires an extra couple of parentheses. And you might see how this is getting a bit complicated. So what it's doing here is at first it's saying we want this function pointer, but we don't care about the pointer itself right now. We want to access the function, so we have to dereference it using that. And that's what this second set of parentheses is it's to help ensure that the order of operations occurs correctly. Because the dereference operator can be a bit further down. And the major thing is that in case one of the things that you might see somebody do is if I did over here, this followed by alist.comp, what you'd have to do then is I would have to do this, and actually toss in an extra one, to replicate the same earlier effect that I had of the hyphen, because this dot operator has higher precedence than the dereference operator does, which means that it would take place before, which is the entire reason we create that originally in C, this whole little hyphen and then greater than was created in order to represent doing that. So that's part of why I'm using parentheses around this dereference operator here, just to ensure that it takes place before attempting to use this here. So now that we actually have this taken care of, let's create our different comparison functions that we can hand to this one here. So one of the things that we can do here is, well, first off, we're also going to have to modify iLinkedList, because in here, as well as we're going to have to update GenerateRandomList. And the reason for a lot of this, and I'm just going to move this guy here, is that if we head on over to GenerateRandomList, oh wait, that's the sorting one. Here we are. Had those slightly out of order. So first off, for createList as well as GenerateRandomList, we're going to have to need some form of, especially when we head into NewList, some way of determining whether or not we want to use a greater than or a less than operator for determining how to sort these. So what we're going to need to do then is, well, first off, let's actually create those two operations, because they're both very simple, and all we have to do is just, let's go sort functions. And the important thing is that because of how we have it declared up here, all we really have to do is do something such as this, delete that, and we can call this one here, let's just say greater than. Keep it nice and simple. And we can go with int A, int B, and then less than. And all that we're going to do is that if A is greater than B, it'll return true, and then for this one down here, if A is less than B, it'll return true. Rather simple, rather easy. Does give a bit of preference to B, so if they're equal, it'll technically return false, but that's not going to impact our sorting. So let's just implement the two of these down at the bottom of our linked list here. Actually, just so as it's a bit cleaner, we can add them into their own file. So new file, we'll just call, oh, whoops. Let's specify that we wanted a C++ file, not a header file. New, actually, you know what? This one here is easy enough, we might as well just define it in here. So return A greater than B, and call that good. Then down in here, we just do return A less than B. And that's really all we need for our definitions of those. So then in here, where we end up doing our generate random list, one of the things that I'm going to do is I'm going to slightly modify this. I'm going to move this up to the top here, and I'm going to get into what srand is in the future. All you need to know is that that basically makes certain that when we end up using this later on, it isn't going to be, it's going to actually be pseudo-random as opposed to effectively the same results every single time. And we'll deal with that in the future when we get into random numbers, but for now we're going to do that there. And then over here, what we're going to want to do is head on down to new list. And one of the shortcuts for basically heading to the declaration or definition of something is that if you hover over something such as down here, remove links, and I press F3, that would actually end up then opening up the correct file, end up taking you to where that is. So that's a nice little handy shortcut. So in here, what we're going to want to do in here is toss in a, and then Boolean, and we can just say use greater than. Realistically, if we want to, we could pass in the function pointer itself as another argument into here. However, for now, we're just going to set it up so as that the initialization down here takes care of assigning either greater than or less than as our function pointer. So we're just going to do that, and then over here, we have to do this, that, And note how in this case here I'm not dereferencing it, and that's because we care about assigning to the pointer, not using the function. So this one here is equal to, and then once again our good friend the old ternary comparison operator. So if we want to use greater than, then we want greater than, and otherwise we want less than. Don't want to include the parentheses after it, and this happens to be how we can then end up using it in here. So now that we've changed the definition here, we need to change the declaration in the header file. So let's just copy this here, since it's a bit cleaner. Hand over, and that one there happened to be new list. We want that there. And then basically everywhere that's using it, and one of the easiest ways to find that is just build it, and it'll pop up a whole bunch of errors for us. If I do this, so there's that. Doesn't do that, and the whole reason why I'm going to do this is that I'm going to take a random integer, and this happens to be a C way of doing random numbers, mod it by 2, and then basically go bool, and we can just call this one B for now. And because it'll either be 0 or 1 due to using the mod by 2, or modulo operator with 2 as your divisor, then we're guaranteed to either have 0 or 1, so either true or false. And we can just pass in. And that should end up fixing it with our next build. However, we do still have another couple of problems in here. So the error that we were running into was that up in here, I had been defining these in here because I was in a bit of a hurry and didn't want to spend the time creating a file to have them in. And the reason why that's a problem, whereas this over here isn't a problem, is that this header file is only included in intro.cpp, whereas this one is used by iLinkedList, it's used by linklist.cpp, linkedlistsort.cpp, and as a result, it ends up having the issue of basically whenever you end up including a header file into a source file, it ends up copying some of that information into there. And as soon as it sees that there are multiple definitions, effectively, because in case I define these in here, that's effectively when it copies it, going to have a copy of that definition in here, and over here. And as a result, the linker ends up having issues with resolving which one it's supposed to use. So rather than having to deal with that, it just throws an error and says, "This is on you to fix it." So my apologies for having been a bit hasty in having done that, but that was easy enough to fix. There were a couple other things I needed to do after that, and just in the sake of saving time, I took care of that now. So, as you can see down here, we're still using this here. The major changes is that in split, I ended up having to copy the comparison operator from the source into the split list, because otherwise it ended up having an error of not having one in whatever you ended up splitting off. So when I would say up here, do this one here, which would split the list into 2 other lists and so on and so forth, then when it tried to go back upwards, in case it tried to use a split list as this list here, it would wind up with an issue of not having the correct comparison operator. So now it does work, does it correctly. It adds on a little bit of time because of the fact that you end up having to, and not to really get into too much of the low-level stuff in it, but basically you end up having to jump in memory and change where your next instruction pointer happens to be dealing with. So as that now it ends up actually dealing with the function that you're trying to use here, rather than trying to, and you end up having to find that function every time you head through this while loop and every time you head through the merge. So it ends up being a fair number of times, but even so it doesn't add on too much to it. So that happens to be the major stuff on how to actually use a function pointer in C or C++. We'll get into some, eventually in case we end up dealing with things such as C# or Java. They have their own ways of letting you use function pointers, and in general, you're not going to actually be using a function pointer too often. So, thank you very much for watching. I hope you have a wonderful day.